everyone. I'm Kanch. I'm a technical solutions manager in Google. What we do is we talk to customers, identify common problems that the customers have, and then build solutions and have it available for them to use. So this solution is based out of the problem statement, which we often hear. Hey, since Q4 of 2022, there is an exposure of I can ask any question, anything, and I'm able to get answers. So one of the things which keeps coming up is enterprises most often have structured data. How do you ask a natural language question against the structured data is where it started. So we'll take you through the journey of the architecture and how you can build it in your enterprise.
I'm Abhishek. I work with Quantiphi. I've been working in the LLM space over the last couple of years. Worked on a very similar text to SQL solution for one of the clients, and ever since I've been working with Kanch to sort of take the solution to market. So, yeah, that's about me.
So let's talk about what we are trying to build. As we talked about it, the problem statement is trying to have a natural language query against structured data. That's like a very common ask. But before we start, there are a lot of challenges with it, which we need to understand of why this is a complex problem to solve. First thing is LLMs by nature is very probabilistic, whereas the structured data querying needs to be very deterministic. So to accomplish that, we need to understand that there are problems or there are challenges which we need to undergo. And that's like the first thing which we need to understand. And LLMs are prone to hallucinations. So we need to understand that there needs to be a sense of tolerance or sense of human in the loop or some kind of feedback set up so that we'll be able to leverage them. And the SQL code generation by itself is a little bit different from the regular code. In SQL code, you need the context of the table, the data, the columns to make the SQL more efficient. And these needs the schema awareness for the LLM to understand and create more effective SQLs. So when we talked about what are the challenges which are faced by enterprise, we understood that it's not just the LLM, which is LLM complexities. It is also the enterprise challenges which comes with having complex SQL, having heavily normalized table structure, because the more normalized it is, the more join statements it is going to be. So if there are 4 tables and the first table has to be connected to the 4th table to retrieve the results, then it makes it very complicated. So when we were working through these kind of challenges, one of the things which we also realized is customers want the answers quick, and they want it quick, and the latency which comes with retrieving the results for these kind of the problems are very minimal. It needs to be very minimal in nature. So when we built the solution, we had multiple users in mind. So we had the data users who are the data engineers, analysts, SMEs, scientists, etc. And there is this business user who are business executive, consumers, internal users, external users who are not SQL savvy, but business savvy, like business experts who are able to ask questions to retrieve the results. So when we think about what we need, we want the customer to be able to ask a natural language question and retrieve the result. We want them to ask questions conversationally. We want them to visualize, extract, and share the results. So these are the 3 goals which we want to accomplish in this solution, which we'll walk through how we are going to accomplish that shortly. And one other thing in the slide is it also needs to be database agnostic. We are not talking about just BigQuery or Cloud SQL or AlloyDB. It could be against any kind of data source.
Thank you, Kanch. So, yeah, I'll go a bit deep into the tech now. So the first slide that I have here is I'll talk about how the data flows throughout the entire pipeline, right? And by the end of the slide, you would realize what we are trying to accomplish here is we are trying to replicate how a human or a SQL expert would sort of go about creating a SQL query given a natural language instruction. So first we get the query, it moves to the semantic layer. The semantic layer is basically aimed at identifying the right set of tables and databases that are required to answer this query. Then we have the extract schema component that basically extracts the schema of the database and the table that would be required. Then we have the query builder, which sort of generates the SQL query, and then finally it runs on the database and generates the results. It's a pretty simple flow, starts with the query, goes through the semantic layer, extracts the schema, builds the SQL query, and finally runs on the results, right? Now, on the next slide, we'll be talking about the architecture. This is a pretty complicated one, so I'll sort of move away from it. But at a high level, we are using components that are pretty scalable in terms of the system design. We have decoupled a lot of these services to be able to improve components individually. As Kanch mentioned, it's pretty database agnostic. We'll be able to run it on different databases, and we're using like PG vector to sort of do the semantic indexing of the databases, right? The next slide, this is the slide that talks about the solution approach, right? If you look at the slide, we have a chat search widget as the input, and the output is basically the user answer, which is the natural language response based on the question that's been asked. The gray boxes essentially are the components of the pipeline. The blue box on the top is the heart of the solution, which is the agent that generates the SQL query. And the box on top is an offline job. It's like a one-time process that's done before this entire pipeline is set up, right? First, I'll talk about what the offline job is and why it's required. The offline job, one, it consumes the database schema, the table definitions, the DDLs, basically, which would be used by the LLM agent to be able to understand the user query, identify the right set of tables and columns that are required, right? And then we have a few known good SQL queries. So this sort of acts like a semantic cache to the agent, where the agent is able to recall some very frequently used SQL queries and be able to provide us context to the model, right? Now going to the solution approach. The first check that we do here is with the known good SQL queries, we first take a look at the user query that's been asked. If we see if it's a known good SQL query that's been asked n number of times, it would simply retrieve it from its memory cache and provide it to the SQL executor, right? The other case might be there might be some degree of similarity in the query that the user has asked. In that case, we pass that as context to our LLM agent, right? That goes further. The next component is infer schema, which is used to understand the schema that would be required to answer the given user query. And that is where we use the table data and the column data that we had indexed. So this is basically table definitions, database definitions, column metadata that helps the model understand which tables and columns are required. And the next is the SQL generation component. I have abstracted it pretty much. There's a lot of complexity that goes beneath it, but high level, there are three components: the SQL generator, SQL validator, and the SQL debugger. The SQL generator basically does, so the agent here, we are following a paradigm of thinking fast and thinking slow. Thinking fast is basically where it consumes the query and the LLM spontaneously generates an answer out of it. The next layer that you see, the SQL validator and the debugger, does the slow thinking, where it validates if the query that was generated was right or wrong, and it becomes an iterative process, right? And we can always set like the number of iterations we want at the trade-off of a latency. So the SQL generator does the fast thinking, immediately consumes the schema, the user query, and generates the SQL query that would be needed. The SQL validator component does a basic syntax check, checks if the query that's been generated is syntactically right, if there are some logical changes that might need to be done, and then it passes on to the SQL debugger. And the SQL debugger here has access to a bunch of tools where it can run like a mock SQL execution to see if there are any error logs that we are getting, right? And that becomes an iterative process between the validator and the debugger to see if the SQL query generated is one, syntactically correct, two, logically correct given the database schema. And the SQL debugger has access to a bunch of tools that helps it runs these mock tests, right? So this is the heart of the entire pipeline where it generates the SQL query. Once the SQL query has been generated, it moves to the SQL executor. And this is pretty database agnostic. We can run it on BigQuery. If it's a BigQuery, then we probably need to do some basic SQL transformations to make it BQ compatible. If it's a PostgreSQL, then we might have to do basic transformations. So the SQL executor is basically primed with the task of executing the query that the agent has generated. It has three components. One is where it runs the query on a database, generates the data frame out of it, and passes it to an LLM to generate the response, which is the final result that we are getting as a user. The second thing is the visualization component. where we are using Google Charts to consume the data frame and generate visualizations out of it. It's a more deterministic process at this point of time that looks at a data frame and identifies, okay, whether a pie chart would fit well into it or a bar graph would fit well into it. So it will sort of give a visualization, but the user has options to change what sort of graph they want. And finally, we are storing the queries and the results for analysis. And this can be further used to probably fine-tune models, do RLHF on the models, look at how well the model is performing, and monitor data drifts and model drifts and all this, right? So high level, this is the pipeline. Consumes the user query, infers schema, generates SQL query, and goes to the executor that does the other operations. And we're sticking to this thinking fast slow paradigm. We've seen it works well for us because LLMs are a bit probabilistic in nature and inconsistent. So having a validation loop always helps in sort of double checking how the LLM is generating the response, right? So this was the baseline solution that we had built, this Dicto V 1.0. There were a bunch of requests that we got from people, a bunch of requests we got from the client, and based on that, we've charted out like a basic roadmap, which falls into V 2.0. This is where we, as Quantiphi and Google, we are collaborating and building some of these enhancements onto the solution, right? The first is embeddings and metadata enrichment. So there have been scenarios where the client data is pretty messed up and there's no table description or database description. So we are creating components that can generate table level metadata, table descriptions that helps the LLM figure out which table and which columns to be used, right? The second is agentic updates. The entire pipeline that you saw is something we have defined in a step-by-step process. We are working on making agentic updates where the agent can itself act like a state graph and iterate across different steps. It can figure out which tool to use. That comes at a cost of a latency and some level of non-deterministic outputs as well. But that is something we're still working on having an LLM be able to plan its steps, be execute, identify the right set of tools that it needs. And then finally, the table grouping component. We've seen use cases where the clients be looking for cross database querying. So they do not want to query from a single database. So in this sort of scenario, we are having tables grouped by which database they belong to. So given a query, the LLM is able to identify it might have to pick a table and a column from a different database as well. So that is one thing that we've kept. Obviously, the databases need to be from the same, essentially, like all should be on BigQuery or should be on Cloud SQL. That part needs to stay same. The fourth thing is improving consistency in SQL generation. We're working on some techniques like self-consistency and tree of thought for it to be able to iterate and run multiple LLM jobs parallelly and use like a majority voting algorithm to figure out which the most consistently voted SQL query that's been generated. So this sort of improves the reliability of the solution. Multi-turn chat is something that we have baked into it. You'll see a small demo on the next slide. This helps a user talk to the database better, and we retain the conversational history, and the user is able to sort of iterate on top of it, ask follow-up questions, and be able to get to the right answer. The third one is improving the defense against SQL injection. So we're building a defense layer that would identify SQL queries that are probably SQL injections or trying to delete a database. So we are trying to build like a multi-layered approach where it would be able to flag suspicious queries or malicious queries. Plus, we are adding a rule-based access control where we are trying to provide access to the users based on their credentials. So we do not want a user to be able to query data from a database he does not have access to. So that is something also we're planning to incorporate. So these are like a few things where Quantiphi and Google, we're working together to make these enhancements to the solutions, right? So here we have a small demo on this one. Kanchana, do you want to talk through this one?
Yeah, sure. So in this setup interface, we have first we are asking a question, and there's no question there, hi there. So it understands that there's no question, there is a false response, and then it asks, okay, how can I help? And then if you look at, can you pause for a minute? So if you look at the questions, it tries to understand the context behind the question. And if it's ambiguous, it tries to ask follow-up questions before jumping into the answer. When it understands the question, again, it identifies the category of the question and it provides the insight from the answer. So it doesn't give you the tabular data, it gives you the answer or insight of the answer. And if you look at the next question, it's completely irrelevant. It's not the same. And then it jumps back between data sets, and it's able to provide the context and give information as and when it comes. And this is one of the things which we have seen customers often ask more and more, and we are trying to build it in the solution.
Any questions, please feel free. Yeah.
My first question is just how do you handle long queries that take 10 minutes to return data, especially when your debugger's iterating through this long query that takes 10 minutes every time it tries a new iteration?
Yeah, great question. So I'll probably switch back to the architecture slide that will help me. Yeah. So there are two levels of checks that we're doing for like long queries that require like longer databases and like tables. One is the table filtering component here, where we are consuming the query, we are looking at the table data and column data that's been indexed, and it kind of fetches only those tables and databases that are required for the LLM model to answer it. So in this way, if your database is pretty huge, but this query does not require the user to sort of look at all these different tables, it would fetch like a filtered list of 3 tables and be able to pass it to the model. So that's one way we are conserving the context length. The other thing is where we are looking at the debugger. Rightly pointed out, there might be issues with regard to context length and limitations. So that is where we are looking at one of the enhancements that I talked about here, where we are trying to improve the consistency using chain of thought, tree of thought, and self-consistency techniques. And here it might not have a debugger associated with it, but the idea here is to run the same query, the same question through the LLM pipeline multiple times and consume like the majority voted SQL query that's been generated. So this way we might not have to go through the iterative loop of going through an agentic debugger, but we'll still be able to get some degree of consistency into the output that gets.
Sorry, just as a follow-up, when you're pulling just a filtered set of data, are you creating like a temp table, or like how do you handle this filtered set of data, and how would you handle that if there's 100 people asking 100 different questions? Now you have 100 duplicate temp tables because they kind of touch the same tables.
Yeah. So I don't think we're creating temp tables here. The idea here is to just consume the table schema. So we're not creating temporary tables when we're doing the schema inferring component. Yeah, we're just consuming the table name, the table description, the table schema at a high level, and we're trying to process it through. So we're not creating temporary tables in the info schema component.
So one thing though, here what Abhishek referred to was more about the schema pruning, making sure the specified columns could be retrieved. I think to your question, if it's a large set of data which has to be returned, like say some query, if it generates like 100,000 rows, and that's going to take time, and if it is going to be in a debugger, it's going to take a lot of time. If that is your question, the more what we are doing today, because I had situations like that, is in the prompt itself, we make sure that, just generate the top 10 results. Because we are, like, I'm very much aware of the latency, cost of latency comes with it. So we are trying to approach it in this way right now, but there could be better ways to approach it. Okay, thank you.